Part 8.4, Impact of Organized Data. In this part, I want to look at this problem. When we organize our data, can we improve the overall performance? So basically, we want to do two ways. We want to compare which way is better. The first way, we do not organize data. We just work on it directly. The second way, let's try to spend some time and pay something first. Because when you need to organize data, you need to pay. Okay? After that, then you solve the problem based on the organized data. Can you get a better overall performance? So that's something we want to do in this video. The question, the problem we want to solve, problem number 5. Element uniqueness problem. So there's the element uniqueness problem. Yeah. Given an array. Okay, yeah. Or yeah, I need to change to n-1. Yeah. Okay, yeah. How to check if all the elements are distinct? We need to do this. Get the answer. How do we solve this problem? So we have many different ways. Here, let us compare two methods. The first method, the straightforward method, do nothing to organize data. The first step, we do not do anything to organize data. Let's just work on the problem directly. So the first step, do nothing, no cost. Then we directly do the comparisons to solve the problem. Okay? All right. Let's start from the first element. Now we want to check if the first element appears in the remaining of the elements. So we need to do a comparison. Compare the first one, position number 1, position number 2, and until we compare all the elements, all other elements. Yeah. So you can see for this step, you need n-1 comparisons. If you find it is repeated, the problem is solved. So you return the answer. Okay. But if you couldn't find this element, the first element is repeated in any of the remaining elements, then you need to look at the second one. Then you do the same thing again. This time you need at the most n-2 comparisons. Okay? And so on. Now, one after another. The second to last one, you only need to do one comparison. The last one, you don't need to do comparison. No. So you can see this method is very simple. Okay? You can find a solution, but you want to know what is the overall efficiency of this algorithm. Okay? Yeah, for the problem, I give you the reference in our textbook, so you can study in this place. Yeah. All right. Let's do analysis. So in our analysis, first, let's look at the best case efficiency. That's pretty easy. If the first two elements are the same, we only need one comparison. Then we can find the answer. So that's the best we can do, one comparison. Worst case efficiency, last two elements are the same. So you have to do all the possible comparisons, and the number for this case, this one, the worst case performance. Next, I may like you to think about the average case efficiency. You need to consider all the possible cases, the average case performance. Okay? Yeah. What is that number? Average case performance. Okay? Yeah. So you try it first. If we have chance, we may need to do that. Yeah. So you try by yourself first. Yeah. Let's look at our second method. Our second method, we pay some cost to organize data. Yeah. So we want to organize the data first. To do that, you need to pay some reasonable cost. So that's our method 2. So we will have an investment step. We do some investment in our data structure. We want to see if this investment can help us improve the performance or it cannot. Yeah, we want to compare. Yeah. So we sort the array first with certain cost. What is the cost? Sorting an array. So here, I want to use some reasonable sorting algorithm. So we haven't learned. Here, I just give you the result. Later, we will learn that algorithm. Yeah. So that cost is n log n. For the worst case, because here, we consider the worst case for this step. The worst case, there is an algorithm, sorting algorithm that can do n log n for the worst case. Later, we will learn that. Now let us just assume we use that algorithm. Okay? So we pay this cost as our investment to organize our data. Yeah. The next question, how to check if any element is repeated in an ordered array. So this time, ordered array, that's our new starting point. We have an ordered array. Now we want to check if any element is repeated, right? Yeah. Let's see, can we do better than unordered array? Doing the comparisons in unordered array and the comparisons in an ordered array. Can we do much better? Yeah. Here we use one simple observation. If we have a sorted data, okay, ordered array, if one element is repeated, okay, then we can find 2 other adjacent elements. They have the same value. 2 other adjacent elements. That is the critical property for this situation. Yeah. So in other words, we only need to do comparison for 2 other adjacent elements. That reduces the comparisons from all the possible comparisons to only the adjacent comparisons. Okay? Yeah. Then we do not need all the possible number of comparisons. We only need part of it. Okay? Yeah. For our pseudocode implementation, we only need one for loop. Just compare 2 other adjacent elements. Okay? Yeah. Yeah. Then we can solve the problem. Yeah. The worst case efficiency, n-1 comparisons. So now you can see we pay this cost. After that, we need to pay a plus. another cost. Together, that's the total cost. Total cost. All right, okay. Now we get results of two methods. Which one is better? Okay. In our next video, our last video of today, we will compare which method is better using theoretical analysis. Okay. All right, so let's stop this video first.